This video, we're going to look at how to identify a linear equation or a linear function. So a linear equation can be written in y equals mx plus b. This is known as slope-intercept form. Okay. Other forms, we could have standard form, which is ax plus by equals c. There's also another form called point slope form, which represents a linear equation as well. All right, also for linear equations, one thing that we can use to recognize a linear equation is the highest exponent of the variables is 1. So we don't have x squared or x cubed, we just have x, right? So if it doesn't have an exponent, then its exponent is 1. So we're going to look at 3 examples or 3 ways we could identify a linear function in this video. We'll look at a graph. So we'll look at, is the graph a straight line? If so, it is linear. If it's not a straight line, then it is non-linear. We'll look at a table. We'll look at the rate of change between the x and the y coordinates. If this rate of change is constant, then it's a linear function. If it is not constant, then it is not linear. And lastly, we'll look at some different equation types. So like I said, the equation can be in slope-intercept form, or the highest exponent of the variables is 1. So we'll start off looking at some graph examples. So are these linear? Well, when we're looking at a graph, is it a straight line? So over here, we're going to say, no, this is non-linear. This is called a parabola. That actually represents a quadratic function. We'll talk about that later. And here we do have a straight line, so that is a linear function. So very easy for graphs. All right, let's look at tables. So example 2, we have 2 tables here. So when we find the rate of change, we're finding the slope, which is the change in the y values, divided by the change in the x values. So a lot of times this is written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or the difference in the y divided by the difference in the x. Okay. So there's a couple ways to do this. I usually start from the right side of my table and I subtract going back to the left. So 18 minus 24, negative 6. 24 minus 30 is negative 6. 30 minus 36 is negative 6. So that's the difference of my y values. Now at the top here we have 12 minus 9, which is 3. 9 minus 6, which is 3, and 6 minus 3, which is 3. So if you notice here, the change in y is negative 6, the change in x is 3, so my rate of change is 2 through all 4 of these points. So this rate of change is constant, so we will say this is a linear function. All right, so the next table, let's subtract. 35 minus 20 is 15, 20 minus 9 is 11, 9 minus 2 is 7. Now at the top we have 7 minus 5, 2, 5 minus 3 is 2, 3 minus 1 is also 2. So now if we look at our rate of change, well, between these 2 points here, our rate of change is 15 over 2. Between these 2 points here, our rate of change is 11 over 2. That's not the same. And between these 2 points, our rate of change is 7 over 2. So this is not a constant rate of change. So this would represent a non-linear function. Okay. And our last example, we'll look at some different equation types. So for our first equation, we have y equals 7. Notice there we don't have an exponent, so we could say the exponent on y is 1. This will represent a linear function, y equals 7. That's actually going to be a horizontal line. Okay. The second one is y equals 2 times the square root of x. Notice we have the square root symbol in there. So that will not be a linear function. That is non-linear. That is called a radical function. The next one, we have y equals 4 to the x power. So is that exponent 1? No, that exponent is a variable. So this is non-linear. That's an exponential function. Okay, the next one, we have y equals 3 divided by x. Okay, you might look at this and say, hey, those variables, they have an exponent of a 1. Yes, but another thing we need to watch out for are variables in the denominator. If the variable's in the denominator, that is non-linear. That is called an inverse or a reciprocal function. Our next one, x squared minus y equals 8. Notice here we have an exponent of a 2, so that would be non-linear. That is a quadratic function. And the last one, y equals 4 times a quantity of x minus 2. Well, we can use the distributive property to distribute this, and it will become y equals 4x minus 8. Notice that's in slope-intercept form, so that is a linear function. So those are 3 ways for you to be able to tell if a function is linear or nonlinear.